Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, everyone, and welcome to this episode of the Trend Detection Podcast. I'm really pleased once again to have my colleague in Australia, Rich Della, on the call. Once again, we're going to talk about mining. If you've listened to the podcast in the past, you'd have heard us discussing many different topics around metals, mining, heavy industry, but today we're going to focus in on a particular use case around mobile mining and forecasting, and some of the results one of our customers has seen from that, which would be really good. But I guess for those who don't know Richard, maybe you could just do a quick intro for people who may not have listened before.
Thank you very much, Niall. I love doing these sessions with you, and I actually get quite a bit out of the other sessions that you do, and very much appreciated. And it's actually great to do these casual sessions to kind of really demystify the jargon and the technicals, and really peer-to-peer discussions are always great. And I really do enjoy your series, and thank you for the invite. Maybe just a recap a little bit about myself. So been with Siemens here in Australia for 18 years, very much in what we call automation and control. Drives and PLCs and instrumentation is kind of really my background and my passion. And throughout my time, I've had to use all of the tools available to justify why a motor had to be changed, or why the customer needs to spend money. And so most of the time throughout my career, I've had to use different tools to justify the means, and that would be exporting to Excel and all of your old traditional ways of justifying and showing to the bean counters what and why it needs to be done. And so this journey that I've gone on with Senseye has been a real shift for me in my career, because I come from a condition monitoring background, and seeing what AI can do in this predictive maintenance space. It's pretty exciting, and thanks for the invite. Much appreciated, Noel.
No problem at all. Happy to have you back. So I guess, like we were discussing, we wanted to focus this episode on a very specific use case in mining, and in particular mobile mining. But maybe I'll let you yourself introduce the topic a little bit more, Rich, and why you decided to sort of focus on this, I guess, as well.
Yeah, no, thank you, Noel. When it comes to mining, there are so many different aspects to it. You've got fixed plants, you've got mobile plant, you've got underground, above ground, and there is no fixed recipe. It really does depend on what you're mining, from coal to iron ore to gold. It really does attract many different methods of mining. And quite generically, you'll get open cut mining, where everything's done with dragline shovels and haul trucks to get the dirt moved around. Or you can kind of go into the underground application, where it's slightly different, but you've still got mobile machinery. I've been quite fortunate enough to be involved with the kind of electrification of mobile mining vehicles, and so I've been working with many OEMs in the large haul truck space. We're talking about the 300 to 450 ton vehicles, the capacity that they can kind of carry. And so I've actually been quite fortunate to be involved in a lot of R&D. I've done a lot of mechanical and electrical conversions. And one of the things that I maybe wanted to talk about today, I think is very interesting, is how we are using Senseye in a mobile mining application. And I think if you speak to anybody in mining, mobile mining is quite unique, because when you look at a mobile mining vehicle, especially if it's electrical, it's a full generation plant on its own, and the amount of variance that a truck or a dragline or a shovel gets exposed to introduces a lot of complexities in trying to analyze data. So if you just try to understand and analyze the fuel consumption of a truck, it depends on so many factors. It depends on loaded, unloaded, uphill, downhill, wet, dry, humidity. So when it comes to trying to apply traditional condition monitoring to mobile mining applications, you really have to think outside of the box. There's no one model fits all. And so that's quite important in this space. And I've been working on this one for some time now, and having a look at what Senseye has done quite specifically to mobile mining trucks, I'd love to share and discuss. But this is quite a challenge in the mining space, is the variance as opposed to a process plant. A process plant still has all of its dynamics, but it's fairly fixed in its data structure, or its fingerprint, as we would call it. A roller can only move so fast, or it's dedicated to the process. But now, if you take just driving home, you just have a look at all of the different situations that you face, and now you try and analyze that data. It's quite a challenge, and Senseye actually brings a couple of quite powerful tools into the space that, maybe we could talk about a little bit more.
No, absolutely. So in terms of what you're saying, so you talked about some of the challenges of, and I guess a lot of it is around sort of contextualization of the data. Because like I said, there's so many variants that you can't pick up, but is it about getting data that's contextualized, maybe?
Yeah, contextualization is definitely the first step in it, because if we look at what a haul truck does, and maybe that's what we'll focus on today, a haul truck will go through an average cycle of where it will get loaded, and it'll move backwards and forwards 3 or 4 times to get underneath a shovel, and then the shovel or the drag line will actually fill the haul truck. Even in that process, there's a lot of G-force, there's a lot of damage that can happen in that period where the truck's actually standing still. And so then the truck will actually move away from the coal face, usually over a pretty bumpy floor of where they're actually mining. And then they will either usually haul, it depends if they're hauling dirt just for clearance, or if they or actually hauling product like coal or iron ore. But usually this would be a 45-minute cycle of where some of these trucks on grade will only travel at about 15, maybe 20 kilometers an hour at best, to actually get to a destination, dump its load, and then basically kind of go through that cycle. And so when it comes to the contextualization, this is quite important. And you need to be able to understand how you correlate data. So just like in the vibration world, in a process plant, you need speed. You don't just want to look at vibration on its own. You need to contextualize that with speed so that you offset the actual vibration to speed. So what we do in basically in the mining space is we need to understand oil pressures and what is the link between exhaust temperatures and how can we protect the major assets on a mobile mining plant, and the assets usually associated with a haul truck would be your engine, be it electrical or mechanical. You're still going to have the engine component. The only thing that differs is that you'll move to either a transmission or you move to an electric system, but you still have planetary gears, you still have suspension, and all of these things start with a contextualization. But what I've actually experienced in my time is that it only goes so far, because you can try and contextualize and use traditional condition monitoring to try and predict something by saying, look, if I'm doing so much fuel burn, I would expect so much heat. And if I don't have this and I don't have that, I expect a problem. And this is where the traditional condition monitoring has really struggled into the predictive maintenance space. Very good for preventative maintenance because, they can raise alarms pretty quickly and they can react. But those traditional tools don't work very well in the predictive space at scale. I know that if you go to one mine site and you put a dedicated data scientist and you put a dedicated application engineer, you would be able to come up with something quite smart, but it'll only be for that site and it'll only be for that plant, or as soon as you move down the road where they operate with different conditions, it's not scalable. And so I think this is the exciting thing that we've seen with projects that I've worked on, is that we are now working in a truly predictive maintenance space. What we are actually doing with our customers here in Australia is we have gone through the process of contextualization and basically looked at how we clean the data without taking away too much and focusing on the long-term picture. And maybe we can go through some of those as an example. Niall?
No, we absolutely can. I'll just ask one quick question, actually. And you mentioned about condition monitoring. I mean, I guess maybe the best way to think about it, and correct me if I'm wrong, but like condition monitoring is more of an entry level towards, if your end goal is to do scalable predictive maintenance, across all plants and production lines. But the starting point for most will be if you can start collecting data. Would you agree with that sort of statement?
Yeah, definitely. And a lot of these mine sites have mature systems. I mean, these, some of these mobile mining trucks, they'll start at 850,000 and they can go up to anywhere, close to 3, depending on the functionality, the size, and everything like that. So they do come with pretty sophisticated OEM protection. And I was actually having a conversation with a customer the other day, and I was talking about the difference between condition monitoring and what Senseye does. And so, and the customer tried to simplify it by making it good or bad. And it's actually, it's not a matter of good or bad. They feed each other. The one protects the other. The condition monitoring is very good for preventative reactive maintenance and stops major failures in their tracks, but it's in real time. So the challenge now comes in is how do you detect problems when it's still within those limits. All right. And this is actually what I've seen in my time, because I've spent a lot of time driving around mine sites with operators in haul trucks. Everybody drives a haul truck differently. And if there's a bump in the road that makes the truck jump, my experience is it's usually a challenge for operators to see who can get the most height out of that jump or bump in the road. And that's normal human behavior, but that puts a lot of stress on the piece of equipment. And if it didn't actually trip an alarm, or if it didn't break anything, a lot of that stuff kind of goes unnoticed. And so it's very, very important that if you really want to improve the longevity of your piece of equipment, that you start with condition monitoring. And the condition monitoring is, as I said, we get you so far, but it won't move you properly into scalable preventative maintenance. And maybe we can go into a couple of examples.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.